Okay, so we're going to work on some multi-step inequalities today, and I've made a few videos for you to see about how you might work on some more complex inequalities. Now, the rules that we use are all the same as the ones we use for the simpler inequalities, just that there are more steps along the way. So here we have 3 times t plus 1 minus 4t is greater than and equal to -5. All right? Now, the first thing we need to do here is use the distributive property. We need to distribute this 3 to the t and to the 1 inside the parentheses. So let's go ahead and do that. I'm going to end up with 3t plus 3, and I still have the rest of my inequality, so I still have minus 4t greater than or less than, greater than or equal to -5. Okay, great. So that was the hardest part, really. Now, before I can go further, I really need to gather my like terms. So I have 2t here, and I'm going to subtract 4t. So when I put all that together, I end up with -t, but I still have my positive 3 that I need to include, and my inequality sign is the same as is the right side. So now this is looking much, much simpler, isn't it? So I'm going to isolate the variable, and I'm going to start doing that by subtracting 3 from this side, and I'm going to subtract 3 from this side. So positive 3 minus 3 is nothing. That leaves me with -t, and that's still greater than or equal to -5 minus 3 is -8. I'm almost there. I've got -t. Now, what I want you to understand is that -t is equal to -1 times t. So we need to isolate the variable by getting rid of that -1. And we can do that by multiplying by another -1 or by dividing by -1. Either way, let's say if I decide to divide by -1, I'm going to do that to each side. Dividing by -1 leaves us with t, but it obviously changes the sign because two negatives, when divided, make a positive. So I end up with positive t. And I need to change my sign at this point. Whenever you divide or multiply by a negative number in a solution for an inequality, you have to change the sign to its opposite. And then obviously, -8 divided by 1 is 8. So here I have my answer. T is less than or equal to 8. So I'm going to not do that. I'm going to erase that, put that down. I'm going to now graph my inequality. So I'm going to bring it over to 8, and I need to decide, this is not working for me. Hello? Okay, well, we're going to leave that there. So I need to decide what I'm going to do with this inequality. In less than and equal to, I am going to have to color in the boundary point because 8 is part of the solution, and less than has me going to the left where all the lower numbers are. So there's my solution, and there's my graph. Now, if we consider going back to the original and testing out a few values, it's kind of challenging when we have so many of them. Let's see if this actually works. So let's pick a value that is in our solution set. So let's go with +5, which is right there, right in the solution set where the pink line is. So if I substitute my t's with 5s, I should get a solution that is true. So 3 times 5 plus 1 is 6, minus 4 times -5 is going to be greater than and equal to -5. So 13 times 6 is 18, and we're going to subtract -20, and that's going to give us a number that is greater than or equal to -5. So yeah, because we get 38 is greater than and equal to -5. So that's perfect, that works. Now let's try an example That does not work. Just erase all this by hitting the erase button about 1,000,000 times. Now, a value that should not work is 9. So let's see what happens when we pop a 9 in there. So 3. So we're going to replace the t's with 9s. That's our first step. And then we're going to solve. 9 plus 1 is 10. And we're going to subtract that, and we're still greater than or equal to -5. This is 30, and we're subtracting 36 is greater than or equal to -5. 30 minus 6 is 6, greater than and equal to -5. That is incorrect, which is what we wanted because the number we use, 9, is not in our solution set. So we can see that our solution, t is less than or equal to 8, is true.